Welcome back, Algebra 2, to the second day of 4.6 notes, the fundamental theorem of algebra. Once again, I want you to keep in mind, how can you determine whether a polynomial has imaginary solutions? So remember, when you have a fourth degree, it's going to have four solutions. Whether they're positive, negative, real, or imaginary, you will have four solutions, okay? If it's a fifth degree, you'll have five solutions. Now, we talked about irrational conjugates before, and this is complex conjugates, which works the same way, okay? So basically, if a minus bi is a solution, so is a plus bi. So I talked about this earlier. If you have 2 plus 3i is a solution, then 2 minus 3i is a solution. Okay, so both of those are solutions because you have that plus or minus that's taken into consideration there. Okay, so it says write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the zeros 2 and 3 plus I. So we have that the solutions are 2, 3 plus I, and if 3 plus I is a solution, automatically its conjugate 3 minus I is a solution. So remember, when we write our solutions, if 2 is a solution, it's written as x minus 2. If 3 plus I is a solution, it's x minus 3 plus I. And then if we have 3 minus I, it's x minus 3 minus I as a solution. I'm going to put the arrow here. Sorry, there's a lot of arrows. The first thing you want to do, though, is you want to get rid of this minus sign and those parentheses. So let's distribute that through, and then we are ready to multiply. And once again, this is going to take up a lot of room, so make sure that you leave space. So we have x minus 2. Nothing happened to that one. That one was pretty easy. So distribute that minus sign through. You've got x minus 3, because it was a positive, and then a negative times a positive I is a negative I. And then end those parentheses. Continue on here. We've got x, once again, minus 3, and it's minus a negative or a negative times a negative, which is a positive I. Okay, so remember, we need to multiply, and you're only going to take two sets of parentheses at a time. Write really small, and I highly recommend multiplying these two first. Okay, so there's going to be a lot of arrows going on here. So we've got x times x. So we've got, by the way, make sure that you're writing out x minus 2. Okay, so now we've got x times x, which is x squared. X times negative 3 is negative 3x. X times x times I is positive xi. Okay, I'm going to continue on. I'm just going to use a different color. I'm hoping this will be a little helpful for you. So negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9, negative times a negative. And negative 3 times I is negative 3i. And then we've got negative I times x is negative ix. Negative I times negative 3 is positive 3i. And negative I times positive I is negative I squared. We're going to come back to that, okay? So I squared, I want you to remember that I squared represents a negative 1. So technically you have minus a negative 1, which really altogether means plus 1. Okay, so I'm going to put that at the end. Now let's just combine like terms. So you've got x minus 2 at the front. And what's really nice is a bunch of stuff is going to cancel out. We've got x squared. So x squared is done at negative 3x, negative 3x. And are there any other x's other than the ix? There is not. So minus 6x. And then notice that we have plus xi and minus xi or ix. So these two right here actually end up canceling out because you have a 1 minus a 1, okay? What's nice is this other I also cancels out. Negative 3i, oops, plus 3i, that cancels out, that goes away. So now we just have 9, and then this plus 1 because it was minus a negative 1 or minus I squared. So 9 plus 1 is 10. Okay, we are now ready to multiply these last two. So let's go ahead and do that. We've got x times x squared, which is x cubed. X times negative 6x is negative 6x squared. X times 10 is plus 10x. And then go ahead and distribute through that negative 2. So we've got negative 2x squared. Negative times a negative is a positive 12x. And we've got negative 20. So now just combine like terms. So we've got x cubed. Negative 6 minus 2 is negative 8x squared. 10 plus 12 is 22x, and then minus 20. And they want you to write that. It says the function f, so we really should write that out with f of x in front of that. So if you were to go backwards, kind of like we did on the first day, or if you were to plug this in your calculator, you would notice that it crosses at 2, but you won't see the other one because it's 3 plus I and 3 minus I. Okay, so Descartes' rule of signs. So I want you to think about that there's positive real solutions and negative real solutions when you are talking about solutions for polynomials, okay? So remember that the number of degrees is the number of solutions, and that could be real or imaginary, positive or negative. So the number of positive real solutions is equal to the number of changes in sign of f of x. The number of negative real solutions is the number of changes in sign of f of negative x. And I'm going to show you exactly what I'm talking about here. So you're going to have to make some room here. There's going to be a chart that we're going to make as our solution. So it says determine the possible, so that's the key word here, the possible number of positive real solutions, negative real solutions, and imaginary zeros for this polynomial. Now I want you to make note, how many total solutions are there going to be? 6 total solutions. Okay, there are 6 total solutions. Okay, now I want you to make note, the signs are obviously in front of the terms. So we've got a positive x to the 6th, and then it goes to a negative 2x to the 5th. So I want you to make an arrow every time you see a sign change. And we saw a sign change there, so that's 1, and I see a sign change here. That's another sign change. So I'm making arrows. Now notice it goes from negative 10x to the 3rd minus 6x squared. So that didn't have a sign change, and the rest of them are all minuses or negatives from here. So technically we had 1, 2, 3 sign changes. So what I want you to do, there are 3 sign changes. So that means that there are either 3 or 1 positive real solutions. And the reason why it's positive is because it's f of x. So I'm going to draw a line here because we found that there's either 3 or 1 positive real solutions. We're going to do the same exact thing, except for this time, we're going to take f of negative x. That means we're going to go up here, and wherever you see an x, you're going to plug in a negative x. Now pay close attention to this, okay? So we're going to put parentheses. Wherever you see an x, you're going to put a negative x. That's negative x to the 6th. Minus 2, oh, I see an x, got to put parentheses, negative x to the fifth. Then you've got plus 3, c and x, you got to put parentheses, negative x to the fourth, minus 10, c and x, we've got a negative x to the third, minus 6, c and x, negative x squared. We are finally getting to the end, minus 8, negative x, minus 8. Okay, before we look at any sign changes, I want you to remember something. I'm going to put this at the very bottom. If you were to do a negative times a negative times a negative, that's a positive times a negative, which is a negative. So this was an odd exponent. If you have a negative times a negative, that's positive. If you had a negative times a negative times a negative times a negative, well, positive times positive is positive. So any even exponent, it will always be positive. Odd can be negative or it can be positive, because what if you had positive times positive times positive? Okay, so that would be positive. Okay, so when you're looking at this, any negative number to an even exponent is basically just going to cancel out this sign. So we're going to rewrite this f of negative x. Because this is an even exponent of 6, that makes any number, whether it's positive or negative, always positive. Okay, this next one, you actually have to keep that negative sign. So a negative x times a negative 2 is a positive 2x to the fifth. Okay, next one is even exponent. So we're just going to ignore it and write what it had. So 3x to the fourth. We've got another odd exponent here, so you got to keep this negative times a negative as a positive, so plus 10x to the third. Even exponent, so ignore that. So minus 6x squared. And then obviously negative 8 times negative x is positive 8x, because that was to the first power, which is odd. So you have to take a negative times a negative. And then we've got minus 8. Okay, let's go through and figure out all of our sign changes. So we go from a positive to a positive. Nope, to a positive. Nope, to a positive. Ooh, look here. We've got a positive to a negative. That's a sign change. We also have another sign change and another sign change. So 1, 2, 3 sign changes. Which means that there are either 3 or 1 negative real solutions. Okay, and that's a big key part there, is real. And once again, the reason why it's negative is because we had f of negative x. Okay, now I have to erase this because we're going to make a chart. Remember, it said find all of the possible numbers of positive real, negative real, and imaginary solutions. So we're going to make this chart here. We've got positive real, negative real, imaginary, and the total solutions. Now remember, the total here should always be 6 because we had a degree of 6, which means that there's 6 total possible solutions. Okay, so now for our positive real solutions, we have either 3 or 1 positive real solutions. So we have 3 real, or we have 1. Okay, so let's just start with a 3. So let's just do that. There are 3 possible real solutions, and there are also 3 possible negative solutions. So let's just start with that combination first. There could be 3 positive, there could be 3 negative, which means that the total needs to be 6, which means that there's no room for any imaginaries. Okay, there could be 3 real solutions, but then there could also be one negative. So that combination would be 3, 1. Now 3 plus 1 is 4. To get to 6, that means that there's going to be 2 imaginary. Okay, so we've taken that combination of 3 real solution, 3 positive. Now we could also have 1 positive. Well, 1 positive and 3 negatives is a combination, giving you 4, which to get to 6 means that you have to have 2 imaginary. And then you have 1 real, and you could, 1 positive, you could also have 1 negative, which only gives you 2 solutions. So to get to 6, that means that there would have to be 4 imaginary. So they just want you to make this chart to talk about all of the possible situations. Okay, kind of like the first example that we did here, sorry, the second one, example 2. You had 5 solutions. Of those, it was -1, -1, 2, and then you had 2 imaginaries to get you to those 5. Okay, and then we have example 5 here. Now it says, a tachometer measures the speed in revolutions in revolutions per minute, or RPMs, at which an engine shaft rotates. For a certain boat, the speed x in hundreds of RPMs of the engine shaft and the speed s in miles per hour of the boat are modeled by the function. So notice that s is the miles per hour, x is the hundreds of RPMs. Okay, what is the tachometer reading when the boat travels at 15 miles per hour? So what they want you to do is they want you to plug 15 in for this. Okay, so if we were to plug 15 in for that, we've got 15 equals 0.00547 x to the third minus 0.225 x squared plus 3.62x minus 11.0. Well, what we want to do is we want to know the real solutions, the real positive solutions, because you can't have a negative RPM. So what you want to do is you need to get this set equal to 0. So minus 15 on both sides, and actually the 15 can only be subtracted from that negative 11. So what you're going to do is you're going to plug into your function, or your y equals, you're going to plug in 0.00547x cubed minus 0.225x squared plus 3.62x, and then you've got negative 11 minus 15 is negative 26. So you're going to plug that into your calculator. So it's nice that we've got our graphing calculator. I would not want to solve that without it. Okay, so notice I already have this in here. What I want you to do once you have that in, so press pause if you need to, you're going to go to graph. Now notice that you can't see this. Obviously we have some different numbers here. So what I want you to do is I want you to hit zoom. And we're going to zoom out. That's number 3. So hit 3. And then notice how my cursor is blinking. We want to zoom out, so hit enter right at the origin. And this gives us enough to see that it crosses the x-axis on a positive setting here. So we want to know where is it that it crosses that x-axis. So you have to figure out where it crosses by going to second calc. We want to find the 0 where it crosses the x-axis. Now we need to go to the left because it says left bound right now. We need to go to the left of our point. Okay, I am to the left of my point. I'm going to hit enter. Now it says right bound. We're going to go to the right of our point. Okay, I went a little far. It would still work though. Okay, now I have my 2 settings here, left bound, right bound. They want me to guess. I do. So we've got 19.86 is where it crosses the x-axis. So that means that the solution is 19.86, but it was in hundreds of RPMs. Okay, so let's just multiply that by 100. So 1,986 RPMs is what that boat is at 15 miles per hour.